You may think of rainbows as magical, mystical, even a little bit mysterious, but they're not. They're an everyday example of science in action. And science can also create a permanent rainbow, right? Well, not exactly. In fact, there's a reason why rainbows disappear after a rainstorm, and it's all because of physics. Here's what happens. When sunlight hits water droplets in the atmosphere, it refracts, or bends, then reflects inside the droplet and disperses as light travels back out. Different wavelengths of light bend at slightly different angles, which separates the white sunlight into its component colors. That's how you get those beautiful red, orange, yellow, green, blue, indigo, and violet stripes. But that's only half of what makes a rainbow. You need two more ingredients, and they both have to do with how light bounces off tiny particles in the air. Water droplets aren't the only things that can split up sunlight into a bunch of different colors. Tiny particles suspended in the air, like smoke, dust, mist, even raindrops, can all cause light to scatter. And when that happens, you see a rainbow. So to keep the party going and keep seeing that rainbow, you need a few things. First, you need light. And while we've got plenty of that on Earth thanks to our big ball of burning plasma up in the sky, you can't just point a flashlight at some water droplets and make a rainbow. The light source has to be big enough so that you get a wide spectrum of colors. So no, your phone's flashlight won't cut it. But a bigger, brighter light source like a spotlight or a laser can work. Second, you need water. No H2O, no rainbow. That means you can't just make a rainbow outside on a dry, sunny day. You need water droplets suspended in the air. Rain mist or even a waterfall will do the trick. So there are two ways to make a rainbow. The first way requires a big light source like the sun and lots of water in the atmosphere, like during a rainstorm. The second way requires a bright artificial light source and a fine mist of water droplets. It's that second way that scientists use to create permanent rainbows in labs. Scientists at Los Alamos National Laboratory used a high-intensity laser to create a permanent rainbow in 2016. The Tansa rainbow appeared on a wall opposite a projector that shot a beam of laser light through a rotating disc that had 100 tiny holes drilled in it. The holes in the disc allowed only certain colors of light to pass through, creating a rainbow effect. The researchers wrote that this artificial rainbow was stable and didn't change over time. But this wasn't a real rainbow made of light refracting and reflecting through water droplets. It was a projected rainbow made by punching tiny holes in an opaque screen. There was another lab-grown rainbow that may look closer to what you picture when you hear the phrase, artificial rainbow. This one isn't made with lasers. Instead, scientists sprayed a fine mist of water into a dark room and shone a regular old light bulb on the mist. The light shone through the droplets and onto a screen where it formed a rainbow. That rainbow wasn't permanent, though. As soon as the water droplets fell to the ground, the rainbow disappeared. That's because a rainbow needs two very important things, a light source and water droplets. And once the water droplets hit the ground, they weren't in the air anymore and the rainbow couldn't continue. Also, the light from the light bulb wasn't intense enough to keep the rainbow going forever. So while this was probably the closest thing to a real rainbow, it still wasn't truly permanent. But here's the thing. Sunlight and rain don't stick around in the same place forever. Even if you could control when and where it rains and where the sun shines, eventually the rain would stop, the sun would move behind a cloud, and the rainbow would fade away. So there is actually no way to create a permanent rainbow that doesn't involve some sort of machine or technology. We can't recreate a real natural rainbow without all the components of one, including the sun, which is kind of a big deal. So while we can't have a permanent natural rainbow, we can use our technology to build our own installations that simulate rainbows. For example, there are rainbow fountains like the one in Cleveland, Ohio. There, water shoots up from the ground and splits into all the colors of the rainbow before hitting the pavement. Or there's the singing ringing tree in Burnley, England. It's a sculpture made of steel tubes that make music when wind blows through them. And when the tubes are struck by light, they make a rainbow too. Then there's the rainbow eucalyptus in Rotorua, New Zealand. This tree was planted in 1934 and is now covered with colorful bands of rainbow eucalyptus bark. When the light hits the wet bark, the tree shimmers with rainbow colors. These installations all rely on us humans to create and maintain them. But hey, maybe someday we'll figure out a way to bottle sunshine and make a permanent rainbow happen all on its own. Until then, rainbows may be fleeting, but science can recreate their magic. Rainbows are pretty rare. I mean, it's hard to get the sun and rain at the exact same time. If you live in an area where rainbows are common, share your tips below so we can try to catch one. While you're down there, make sure you click subscribe because there's lots more colorful science wonders headed your way. Thanks for watching.